The Tesla coil. Wireless electricity is here, from wirelessly powered lighting to wireless chargers and even wireless smart homes. Wireless transmission of power is an emerging technology with innumerable applications. A light bulb powered with no wire, a cell phone charger that does not need to be plugged in, a home with no plugs, no wires, and everything just works. It's not magic, it's not mystery, it's science. The invention of wireless power transmission is typically attributed to 20th century inventor Nikola Tesla, though the technology may have been in use much earlier. Since then, however, improved designs and modern components make this an easy project anyone can do with just a few simple parts. Let's get started. Fun fact, a Tesla coil can even create mini lightning bolts that spark from the surface. Caution: do not use near persons with face marks, sensitive electronics, or flammable materials. Here's how it works. Electricity needs to travel through wires, right? Well, not anymore. This simple device shows how electricity can be transmitted wirelessly to power all types of electrical devices for convenience, necessity, or just plain awesomeness. Here's how it works. We are creating a system that converts a low voltage to a high voltage and simultaneously turns itself on and off very quickly. That's all it takes to transmit wireless electricity. A few watts of electricity are passed to one side of a coil of wire and to a grounded capacitor connected to the negative side of the power supply. The other side of the coil is connected to the collector of a transistor, a device that can turn off the flow of current based on an input signal and then to ground as well. This causes two things to happen. The capacitor begins to charge while the coil begins to radiate an electromagnetic field. This secondary coil is then connected to both a resistor connected to the power source and the base of a transistor, which then shuts off the flow of current to the first primary coil. This circuit configuration creates a feedback loop which automatically turns on and off the secondary coil hundreds of times per second, which creates a high voltage, high frequency electrical field capable of transmitting wireless electricity. Fun fact: a transistor is what makes the processor in computers work. So in essence, we are building a super simple computer to control our Tesla coil. What you will need. The coolest thing about this project is its simplicity. This is the world's simplest and easiest Tesla coil circuit designed with just a few simple parts. You will be creating your own mini lightning bolts and powering things wirelessly in no time. Here are the parts you will need. Breadboard circuit, MZE3055TT transistor with heat sink, 1041 ceramic capacitor, resistor, solid core, insulated copper wire, insulated magnet wire, steel washer, jumper wires, power supply, plexiglass sheets, threaded rod, nuts, washers, rubber, and caps. Also get the circuit diagram here. Fun fact: Tesla used a high voltage spark gap to control his circuit. We will be using something a bit more modern and reliable, an MZE3055T transistor. Wind your coils. Wind your coils. To begin, we will need to wind our out coils. To do this, we will need to be precise and accurate, otherwise our coils won't function properly. First, we will make our primary coil. We will wrap our short 2.5 PVC pipe with the 16 GA insulated copper wire, making 3 rotations evenly spaced about 1/4 apart and secured with tape. Then strip the ends. Next, we will take our 2 PVC and line up the magnet wire across about 1/4 from the bottom and secure it with tape, leaving several inches extra on the end. Now comes the tedious part: to get comfortable. We will now wrap the magnet wire around several hundred times until the round reach 1/4 from the top. Also be sure to add a piece tape of every inch or so to keep sure. Once you reach the top, leave a couple into the additional wire. Then you can secure your winding by wrapping a tab from top to bottom. Lastly, press the restricted wire end between the top of the PVC and your 3 washer and secure with glue. This will act as your secondary coil and transistor cap. Easy Tesla coil circuit diagram. There are only a few parts, so building your circuit is simple. Just make sure to have circuit diagram handy while following along. First, we will install the 3 legs of transistor in breadboard slot C1, E2 and E3. First, the heatsink and front of transistor facing back towards slot S. Next, we will insert the 3 capacitors into slots respectively. Now, let's connect the first step of the transistor to one side of our capacitor with the jumper wire. Connect one end of a jumper wire to slot D1 and to other F14. Next, we will connect a jumper wire from the other side of our capacitor back to where our ground will be. Next, connect the one last jumper wire to slot A5 and the other end to slot B11. This will allow us to connect to our primary coil. We will now insert our secondary coil into our primary coil, keeping it centered. Check all connections before proceeding. Lastly, connect the positive from your power supply to slot V5 and connect the negative from your power supply to slot V1. You may now carefully test your circuit by plugging it momentarily. To avoid overheating, only power your Tesla for short duration of no more than 20 seconds. Construct the enclosure. Now we will build an enclosure to display our Tesla coil. First, we will place a washer, nut and cap on each of our thread rods. Then we can drill a 5/16 hole in each corner of our plexiglass sheets. Then insert the 4th rod into the holes in one of your plexiglass sheets and add a washer and nut to secure, creating the base of the enclosure. Next, place your circuit and coil on the top. Lastly, add a nut and washer to each of the rods. Place the second plexiglass sheet on the top. Adjust in order to tightly hold the coil in place. Once secure, add an additional washer and nut to each rod. Tighten and add an end cap to each. Your enclosure is now complete and your Tesla coil is now ready to use. Step 6. Experiment, observation and operation. Now that your Tesla coil is complete, you can begin your experiment. You can now connect the power and watch the fluorescent bulb light up like magic once placed near the coil. Watch a spark fly when metallic objects are placed near the coil. Use a digital multimeter to observe the high voltage field at various distances from your coil. Want to take it a step further? Add a resistor. Add an LED to create your own wirelessly powered light bulb. What real-world application does this technology have? How can this technology be used in future? Give this project a try and let us know how your comes out by posting pictures, comments and questions in the comment section below. Thank you.